Okay. For those of you listening at home, howdy. We just started notes. You can thank one of your dear classmates for saving our bacon by reminding me to turn the video on. Okay, gentlemen, drag your attention back up here. Conics. Conics in this chapter, by the way, we're fast forwarding. Oh yeah, I didn't get a chance to say, I'm still working on the tests. God willing, they'll be done tomorrow. For now, we're taking a sneak peek into chapter 6, which is, they call it analytic geometry. I'm just calling it conics. Same thing in this case. Conics are slices from what we call a double cone. And here's an example of a double cone. Just ignore this line for a second. Draw two ellipses or ovals, and then connect one edge to the other edge crossways. And that'll make sort of an illusion of a cone that's sitting on a table, and then an upside down cone that's balancing on point to point. Okay. If you were to take this, can everybody picture that in your head? Okay, this is a circle if you looked at it from the top. So it's sort of tilted away from us, so we're looking at it edgewise. If you sliced it exactly across, this is like, so this thing here is what we'll call the base. It's kind of like the bottom of a statue. That's what you call, base of a triangle is the bottom of the triangle, etc. This is the base. So if I cut perpendicular to the base, can everybody in their imagination tell me what shape you get? Like if this is a three-dimensional cone, and I take a hot knife and I slice through it in that direction, and then lift it up and look at the cut, what shape will it be? Yeah.
A trapezoid?
Well, this is round. I wish I had one. Do I have a cone? I gotta buy one of these things. Go. It's a circle. Does that kind of make sense? If you're looking at, well, kind of like this. This is what's called a cylinder, yeah? A cylinder, I mean, it's got a water bottle, but pretend it's just solid cylinder. If I sliced it like this, and then I looked at the cut, what shape would the cut be? It's a circle. Exact same thing, except this is getting smaller, smaller, smaller. It's kind of like an ice cream cone. The old-fashioned ice cream, not the ones that just squared off, the cheesy-looking ones, but the really good waffle ones that were. I've been allergic to these for like 25 years, but I assume they still make them. But you've seen ice cream cones that come to a point, right? Okay, good. Good. So if you sliced it perpendicular to the base, you're going to have a circle. What if you cut it slightly at an angle? What if you cut it a little bit at an angle? This is going to cut, I'm going to give you a new word. Obliquely, which means crooked. Obliquely to the base. Tell me what shape that would get. Yeah. Actually, it wouldn't be. It'd be a little longer than a circle. You're close. It's going to be an oval. We call it an ellipse. Oops. Which is sometimes called an oval. So a circle is going to look like this. An oval is going to look like this. Understand? There are two more types of cut I need to make. The third is if I cut straight down. Does everybody notice that this cut is going to hit twice? It's very hard to see what shape it is, but if I cut, oh, sorry, I'm an idiot. Wow. You see this first one where I said cut perpendicular to the base? That's parallel. Wow, what was I doing? Because this one is perpendicular. Did we catch that error I made? The first cut is parallel to the base because it's going the same way. Wow. So what I have to do is knock the internet out of my room and I get completely muddled. If you cut perpendicular to the base, it's going to look kind of like this. There's going to be a branch above and a branch below. It's slightly rounded. They're going to go forever. cone goes forever. This, you might or might not have heard this word ever before. Called a hyperbola. A hyperbola. This may be the first time you've heard the word. If so, congratulations. A hyperbola has two branches. And it also has two asymptotes. The asymptotes are a little weird. They go diagonally. So both graphs get closer and closer to those diagonal lines and never touch them. Does that make visual sense at least? Nobody would have known this unless you just physically cut one of these things. I had one of these, at my previous school I actually had one of these. It was transparent and they had the slices colored in red and said it was really slick. I might just have to break down and buy one on Amazon. But there, yeah, anyway. One last cut. And this took a long time for mathematicians to discover. What if you cut exactly parallel? See these little arrows, remember from geometry? If you have two lines that have same number of arrowheads, that indicates parallel. So these are going in the same direction. Should have gone a little bit steeper. What kind of shape do you get there? What kind of cut? So if you cut parallel to the slant edge, what do you get? It turns out it looks like this. You recognize it? What does it kind of look like? It's a parabola. And that's what it is. It's weird that it would show up in a shape like this, but it does. It's very hard to get. You have to cut it exactly parallel to one of the slanting edges. But you will get a you will get a parabola that way. So there are 4 types of conics we're going to be studying. Circle, ellipse, parabola, hyperbola. By the end of this chapter, we're going to now know how to graph all of those. And we're going to know how to analyze all of those, which means give all their parts. Like a circle, okay, geometry, remembering people. There are 2 things required to build a circle, like a specific circle. What 2 measurements or objects do you need in order to create a basic circle? Go.
Like a radius?
We need a radius, and we need
Like a circumference.
circumference can be found from the radius. You do need a circumference, but I can get it from radius. There's one other thing, in order to actually draw it. Yeah.
Maybe like the center?
The center, correct. The circle needs, so the parts, it needs a center and a radius. That's the first shape we're going to be playing with. Now let me show you how this works. For example, take a look at this. Can anybody identify the shape? It's from last chapter. It's a parabola. Anybody identify the form that this parabola is taking? Name. Welcome back. What form does this parabola have? There are 3 forms we covered. What? It is vertex form. Good. This is vertex form of a parabola. Prove it. Where's the vertex? Josh. Where's the vertex on this thing?
That would be 1.3.
Correct, 1 comma 3. This is a parentheses x minus h parentheses squared plus k. Y equals. And the vertex is h comma k. What does a stand for? Yeah.
The height multiplier?
Height multiplier, correct. In this case, the height multiplier is -2, which means it's twice as tall, and it's upside down. Is that right so far? Double check. So we have 220. So we got about half hour, okay. I want to show you a different shape. We actually had this on an extra credit question in one of the previous tests. X squared plus y squared equals 25. I'm curious what shape that is. Right.
That'd be a line.
It looks like a line, and it would be a line if you didn't have the squares. X plus y equals 25 would be a standard form of a line.
That'd be a circle.
It's a circle, baby. Let's find out. Let's pretend nobody's ever seen one of these before. Give me a point that you're pretty sure will work. Pick any x and any y you want, as long as the first squared plus the second squared equals 25. You can be as easy or as hard or as exotic as you want. Pick an easy one. I'll give you a hint. Think chubby hand method. Go.
5 and 0.
5 comma 0. Give me another one.
0,
0 comma 5. Let me see why those work. 5 squared is 25 plus 0. It works. So let me graph that. And then 0 comma 5. Can we give me another number? Pair that works? Okay. Similar to those. I'll give you a hint. They're being squared. -5 comma 0. What's another one?
0 comma -5.
Ah. Here's the third point. Here's the fourth point. That might give it away. Whatever shape has to hit those 4. Now let's get a little more exotic. Oh, people who remember geometry. Oh, people who remember the Pythagorean theorem. Oh, people who remember maybe what we call Pythagorean triples, which is common triples that make right triangles. Does anyone remember the most famous of them, the easiest one? They're all whole numbers. Very close. Other direction. 3, 4, 5. 3 squared plus 4 squared equals 5 squared, which means, by the way, 3 comma 4 will work. Check it out. What's 3 squared? Anyway, 9. 4 squared?
16.
What's 9 plus 16? Ding, 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 ding. So 3 comma 4 works. I didn't draw this very well. 4 comma 3 also works. -4 comma 3 works. -4, -3 works. Do you get the idea? -3 comma 4. -3 comma -4. And I think 3 comma -4. 4 comma -3. Yeah, it's a circle. It's a badly drawn circle. Let me see, at least plugging it in how we got that. This was just by shooting in the dark and saying, let's find some points of work. Well, let me give you a formula. A circle has a general formula just like a parabola does. It looks like this. Parentheses, x minus h parentheses squared plus y minus k parentheses squared equals r squared. That you'll need to memorize. Let me give an example of what it looks like. Parentheses x minus 3 parentheses squared plus 1, what am I doing? Plus y minus 1, parentheses squared, equals 4. That, if the formula works, should be a circle. Does everybody have these cut notes? Yeah, of course.
Just wondering, with the graph of a circle, doesn't it fail the vertical line test?
It does. So a circle is never going to be a function. Correct. So these are not going to be functions, but they will be interesting. As a matter of fact, most of the graphs we're going to be making in this chapter are not going to be functions. An ellipse is not a function. Parabola is a function if it's going up and down. If you go sideways, it messes it up. And a hyperbola is usually not a function. Rare exceptions. Here's a question. Can you graph this one? According to the formula, it's a circle. Can anybody tell me where the center is? Go.
3, 1.
Yeah, it's a lot like vertex form, except, so the center is h comma k, which in this case is 3 comma 1. If you'll notice, there's a minus in front of the h and a minus in front of the k. It's kind of like a double vertex form. In other words, you take the number after the minus and the number after the minus. So this is not -3, -1. It's 3 comma 1. It's a lot like point slope form. It's a lot like vertex form. This is the part that might stretch your brain a bit. If I ask where's the input and where's the output, two-part answer to that. Number one, this is not a function, so it doesn't have input and output as we understand. But, in a sense, both the x and the y are input, because both of them are in parentheses being squared. So both of these, inside here and inside there, everything does the opposite of what you expect. Otherwise, you can just memorize this. The center is this number comma this number. Can somebody guess at the radius? Here's the formula. Here's the number. Yeah.
Would be 4.
Close.
2.
It's 2. The radius, this is the radius squared. It's already squared. So the radius is 2, which is radical. It's radical 4. How do you graph it? Go to the center, 3 comma 1. Put it down. There's the center. Then when you're graphing something of radius 2, I would suggest making 4 points. They call them the 4 cardinal points. It's kind of like north, south, east, west. 2 spaces up, 2 spaces down, 2 spaces right, 2 spaces left, and then try your best to make a realistic looking circle. There you go. Does that make sense? So when I say to graph a circle, you just did. When I say to analyze a circle, all I mean is if I give you this, can you give me the parts? The center and the radius. So you've just graphed and you've just analyzed the circle. Analysis means give me the parts, like the center and the radius. And then graphing is draw the picture of it. Yeah.
So the minimum amount of points for a circle is 5, like a parabola is 3.
Including the center.
Okay.
Correct. Yeah. I mean, could somebody freehand it with like 2? Yeah. I would say a minimum of 4 points around the edge and the center point. Yeah. Does that make sense? Let's try another one. See how this works. I want you to graph and analyze this shape. X plus 3, parentheses squared, plus y minus 4, parentheses squared, equals 49. First of all, Mary, what shape do you think this is? It's a circle, right. Why would you say, if somebody asked why, what would you say? There's not a heck of a lot to say on this point, but what made you think it was a circle and not a parabola? Because both of them have things that are squared.
Because you're adding two squares.
Yeah, you're adding two squares, x is squared and the y is squared. And by the way, a little visual here. When you have just one variable squared, like x squared, like if you just have, let me, quick example. If you have like x plus y is equal to 5, what shape is that? It's a line. It's x-intercept of 5, y-intercept of 5. Straightforward. No pun intended. Straight. But if I do this, if you square, anytime you square something, you bend it. You bend it from straight to curving. This one about if you subtracted x squared, this would be y equals negative x squared plus 5. So that's up here. And then it goes downhill. Does that make sense? When you square the x, it bends in a particular direction. What happens if you square both of them? Not only do you bend it in one direction, you bend it in the other direction and it closes in. So it bends in the left-right direction and it also bends in the up-down direction. So anytime you have an x squared and a y squared added up, you're going to get a circle. Okay. So far, that was foreshadowing. Now, if this is a circle, by the way, on the test, I'm going to say identify, graph, and analyze. And all I'm going to give you is the equation. So identify, it's a circle. That helps you graph it, by the way. Because if you're trying to graph a line, good luck with it. Because it's not. Then, I want to analyze it first. Nate.
So, where'd you get the center?
Which is what?
Maybe negative 3
Where'd you get the negative from?
Well, because the formula is a negative, so it's positive. Because it's actually.
Yeah, correct. You remember the old days when, good save, by the way. If you, in the old days when we had point slope form, and they had a plus there, you had to change it to minus a negative. That's exactly what you have to do here. This is x minus negative 3. So, I'm sorry, say this, center again.
7 is negative 3,
Negative 3 comma positive 4, correct. And then what's the radius?
maybe 7.
The radius is 7. Because this is already squared, so you have to unsquare it. Make sense? Now graph it. Where do you start? Rebecca. Center, where? Right, negative 3 comma 4. I'm going to fake that here. Because I'm just tired of drawing dashes, and because it's going to be really big. Where do you go from there, just physically? How do you draw your circle? 7 to the left? 7 to the right? 7 up, no reference to the soda. And then 7 down. So you're at 4. You'll have to go up to 11. I would strongly, strongly urge you to mark the numbers you get. Later on, I'm going to ask you for those points. So 7 down is going to get you down to negative 3. 7 to the right gets you over to 4. 7 to the left gets you over to negative 10. I would mark those. I would strongly, strongly urge you to mark those. Because especially when we start doing ellipses, we'll need those. So anytime you count over, mark it. Even if it has dashes on your graph, I would strongly suggest you put the number, mark it. Does that make sense? Do you think you could do that if I gave it to you on a test? So if I gave you the formula, could you recognize it as a circle? Could you get the center and radius? That's called analyzing. And could you graph it? If you can, then you're in good shape right now. Now, I'm going to throw a curveball. Yeah, question.
I'm sure we need like 2 points to figure out the rest of the circle.
Well, unless they're like right above each other, but if you get like 2 points that are like diagonal from each other, then you know that those are on the edge.
And the center, you mean?
And then.
Are you assuming you have the center or no?
If you had like the center and then any other point, you could figure out the rest of them.
Correct. If you have the center and any point whatsoever on the edge, you should be able to find it. Speaking of which, you just read my mind. A circle has, wow, has center. I sometimes put little stems on the C to make sure it's a capital C. I know it looks like a horseshoe when I do that, but it keeps it from looking like a small c. A circle has, a circle has C of 1, 5, and goes through let me see, 5, 8. Find its equation. Go ahead and write that down. A circle has a center of 1, 5 and goes through the point 5, 8. The actual circle goes through 5, 8. Find the equation of the circle. Where do you even begin? Yeah.
You can do the first part because you have the center already.
Okay. So what should I write?
You can do x minus 1.
Yeah, x minus something. I usually do blank, kind of like the Pythagorean theorem, or quadratic formula, Pythagorean theorem. Squared plus y minus something squared equals something squared. That's what a circle formula should look like. What goes here? 1. And what goes here? 5. You're actually 2/3 of the way down. Congratulations. Finding the radius. Yeah, question.
Okay.
Okay. Did they give us the radius? No. Oops.
This is like a long way of doing it, but if you could graph it and figure out how far away from this.
Not a bad idea. Actually, it's a very good idea. So 1, 5, I'm just going to whip out and do this. And 5, 8. Drawing the circle is a good idea. I'm just going to do a dotted circle. Should kind of sort of look like that. What piece of information is stopping me from finishing the problem? Okay. What do I still need? The radius. Is there any human way to do that? Yeah.
Distance formula?
Distance formula. Oh, from geometry. The one that everybody hates. There are only 2 points I know, so if I can find the distance between those two, we got it. By the way, oh geometry people, what is the distance formula? No, don't make me remember. I just got out of 6 months of therapy for this. Go.
Is it like x2 minus, no, exactly.
Kinda, sorta. The big, huge radical. X2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. By the way, little hint, if you squared both sides of this, you'd get a circle formula. This is something minus something squared plus something minus something squared. And if you squared these, this would be squared. Yeah.
Could you just plug the point into the figure?
Indeed you could. So x2 and y2, x1 minus y1, I'll show you a trivial way to do this first, and then I'll do the formula. Oh, geometry people. How long is that? Just count it out. 4. How long is that? This is an 8, by the way. This is 5, this is 8. 3, thank you. What shape did we just make? Oh, geometry people? Sam. What kind of triangle? A right triangle. What formula always works with a right triangle? Hush. Don't even listen to them. Pythagorean theorem, which is?
A squared plus B squared equals C squared.
Very good. A squared plus B squared equals C squared, where C is the longest side. 3 squared plus 4 squared equals something squared. I'm going to call this the radius. 3 squared plus 4 squared equals radius squared. Do it. Josh, take over. 9 plus 16 equals r squared. Don't put it, by the way, don't do this. People get so proud of themselves for doing arithmetic that, oh yeah, I got it. You just killed your r. It's dead. Yeah, question. Yes. Go ahead and do this anyway. 16 plus 9 is what? Take over. 25. What's r? Yes. The radius is 5. Now, if you had tried it in here, you have to decide which point is which. I'm going to use this point as x1, y1, and this point is x2, y2. It would look like this. 8, y2, 5 minus 1, parentheses squared, plus 8 minus 5, parentheses squared. You'd get 4 squared plus 3 squared, which is radical 25, which is 5. So it does work. I just wanted to show you that the distance formula comes from the Pythagorean theorem. It's the Pythagorean theorem turned inside out, basically. We got about 5 more minutes, just in case anybody falls. Still following? Does it make sense? Now I just want to simplify this. X minus 1 squared plus y minus 5 squared equals 25. And that's what I would want on your test for an answer. Does that make sense? So we've covered 2 main things. How to identify, graph, and analyze if I give you the formula, and then going backwards. If I give you some data, the analysis, can you go backward and find the formula it came from, the equation it came from? If you can do both of those, you're in very good shape for the first section of this chapter. Make sense? Last but not least, last problem of the day. This is a little bit of a detective problem. Yeah. Does that mean need this thing right here? Am I still writing this? Okay, speak now for hold your peace. Okay. And some space. A circle has a y-intercept. Let me think. Hang on a second. Yes. Of 6. And x-intercepts of, hold on a second. Hold on. Don't look. Okay. And x-intercepts of 7. And I'm not sure this. Darn it. No, I'm sorry, I'm gonna have to cancel this one. I gotta look it up and up. This is one that you have to do it very specifically, otherwise you get an imaginary number. Never mind. switched up phone one too, never mind. Ah. Any questions on what we went through so far? Okay, so, step one, memorize the formula for a circle. X minus h parentheses squared plus y minus k parentheses squared equals r squared. That will be on the test. Second, know how to identify, graph, and analyze a circle if I give you a formula for a circle. And if I give you data, know how to go backwards and find the equation of the circle. If you got that, we've got that section. So, 3 more minutes. Go ahead and let your brains cool off. No homework. Yeah. Don't get used to it. You do.
Does straw have one hole or 2 holes?
Does what?
A straw.
Does a straw
There's 1 hole or 2 holes.
1 hole or 2 holes? Wow. Believe it or not, that's a deep question. There's a math class in college called topology. Topology is the study of interconnected things. For example, can anybody picture a donut? A typical donut, not the cream filled stuff, but the ones with a hole in it. Now can you picture a coffee mug? Like a regular coffee mug. I've got here. This is a plug for the class called topology in college. This is a mug of coffee. In topology, the only thing they're really concerned with is how many holes are punched into the thing. If you had like a donut made out of silly putty or clay or something, you could stretch the donut really far, mush it around, make one of them. You could take a donut and shape it into the shape of a mug. If it's made out, you'd have to, this would be most of the donut, and then you'd have to like take your thumb and mush one side and sort of make it spoon up a little bit. In other words, as far as topology is concerned, a donut and a coffee mug are the same shape. They don't care what form it is, as long they're just counting how many holes are punched through. So, as far as topology goes, there's only 1 hole through this, because this isn't a hole. It's just dented. And then for a straw, in topology, there's only 1 hole.
Yeah, but
As far as human beings are concerned, you could probably talk about ends. Like there's one end of the straw and another end of the straw. And by the way, in topology, there's no difference between a donut and a coffee mug and a straw, because they all have 1 hole punched through them. I had horrible study habits in college, so I had to drop topology, but take it. It's actually rather fun. As far as topology is concerned, a shirt has 3 holes, not counting the buttonhole. Please stand. It's the neck, and this, and actually 4, because there's, well, no. Wow, I'll have to think about that. I'm not sure. Let's write. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and the Holy Spirit. And bye, everybody. Thank you very much.